Good afternoon, it's Lee Cassidy from Tactile Technology, and it's our regular Tintri Tuesday. So we talk all things Tintri. Last week we had Ross Cooper Smith with us talking about IntelliFlash. And one thing we ran out of time towards the end, so we didn't get to cover some of the reporting and management interface. So that's what we're going to pick up today. So, how are you, Ross?
Not bad at all.
Not bad at all.
Good, good.
How are you doing, Lee?
Yeah, so we're going to cover off the IntelliFlash's management console, but this is the software service one, so over the internet, which we can actually do quite a lot more than just manage the box with it, I believe.
This is really the primary interface for IntelliCare, which is the cloud management console, and I recommend pretty much every customer. This is your primary interface for logging in and managing the arrays. That's what it's designed to do.
Okay, so are you going to show your screen and then we'll get cracking?
Yeah, absolutely. I'm going to start with a little bit of a refresher. If I just bring up the kind of the summary page for IntelliFlash and build this out.
Okay.
This is what we covered a couple of weeks back. And just to remind people that maybe either haven't seen this for a while or are new to this video, the kind of core concept of IntelliFlash is pretty much every estate these days is heavily virtualized. The vast majority of people are 99% virtualized or even completely virtualized. And it means that you don't need to go to the storage very often. Once these are deployed, it's really common for them to just sit in the data center for 2, 3, 4 years, and no one ever needs to touch it. Because you're deploying virtual machines from vSphere, you're managing, adding capacity to virtual machines and projects through vSphere, you don't need to micromanage the storage array. And it's changed what you need, and it's changed kind of the concept of what we designed with IntelliCare. So it's designed to be easy to use. You've got to be able to pick it up quickly. It's got that central management. It stays simple over time. It integrates with the VMware. And one of the big changes of all of that is the primary management interface of IntelliCare. If I bring this onto the screen, this is a cloud management console. So this can manage any number of arrays across any number of data centers all over the world. One of the core concepts is because you don't need to make changes to the array very often, you can do an awful lot of the data management for your arrays from a secure user interface that is read-only, that has no access to data. It's one of the core differences between this is a cloud management console and a lot of the other cloud management consoles you see out there.
Yeah, I think people are worried about security these days, so having that read-only availability and secure access to it is a real bonus.
Yeah, and it's not a theoretical risk. There's been real instances of that. There've been cloud management instances that have been compromised, and that gives attackers access into just hundreds and thousands of company systems. So it's rich pickings for attackers. So it is a common target. The beauty of IntelliCare is I'll show you what you can do in terms of functionality, but just bear in mind all of this is secure. There's no way to make any changes. There's no way to reduce your data. There's no way to view any data, any documents within the estate. So if we just start with a quick tour of the home screen, and I'm just going to try and keep an eye on time because I can talk about IntelliCare for hours.
Yeah, we're a bit limited with we don't want people going to sleep on us.
No, well, hopefully not. If you're concerned about that, grab a coffee before I start. So on the home screen, top left, you can see how many arrays you're managing today with your IntelliCare console. So this is our demo lab. We've got demo systems all over the world. We don't have one in the middle of the ocean. We've just not actually changed the address on that from the zero line. So that's a new system that's not been updated correctly. But generally speaking, you can see exactly where they are. We do have arrays sitting in the ocean, but they're with other customers and they're floating around here somewhere.
Yeah, well, Microsoft just lifted one of their data centers out from underneath the sea, didn't they?
From the seabed.
Yeah, so you never know.
They're designing it for kind of 10, 20 years submerged. So yeah, you never know. A few years' time, could be a data center of the future. So we've got 12 arrays within the demo lab. Of those, we've got 8 that are actively being monitored by IntelliCare, 4 that are inactive. Now, inactive doesn't mean it's switched off or idle or not working. It means it's not actively being monitored right now. So in our case, that's very often it's in a lab location that doesn't have internet access. Maybe it's in testing for one of our secure clients, so we're not allowed to put outbound access on that system. So it just lets you know the health and whether you've got any that aren't being monitored. Unregistered means it's a new array that you've ordered, may have been delivered, but you've not yet logged in and activated it and linked it into IntelliCare. And all of this, by the way, is opt-in. So it is secure. It is designed to be used even by very large corporates, but it's completely under your control. You can choose not to use this if you wish.
Yeah, because there's always going to be someone that says we don't really want access to our systems in real time because of security concerns.
The reality is there's very few. I do get every so often people that are concerned about security and ask the questions. And when we explain the architecture of IntelliCare and we go through the details of what data it saves and how it works, generally speaking, it gets passed by an awful lot of security audits. Just the design of the architecture is inherently quite nice.
I would assume as well, this is only metadata rather than the actual user data that's accessible through it anyway.
Exactly. So there are going to be instances where this is still more than a business is happy, and for that we can deploy it on site. But 9 times out of 100, people use the cloud instance. So unread alerts. Alerts on IntelliFlash are split into really 2 types: your critical, non-critical. So the critical are your classic kind of hardware failures. So a power supply's gone, or a disk needs to be swapped. Someone's knocked a power cable, a network cable's been pulled out. It's something that's physically happened. It's probably not going to take the array offline because everything is redundant, but it needs manual intervention to correct it and get you back to that fully resilient state. So that's why we call it a critical alert. We want to raise your attention to this and say, look, we want you to take action. Most critical alerts are going to raise a support ticket automatically, so our team will be in touch with you, but it's still going to need someone to book a ticket with the data center, arrange access, and actually go and physically swap the part out. Non-critical are generally the more proactive alerts. So again, this feeds into the fact that we don't expect you to be logging into this all the time. So if we see something that we think you might want to look at, we'll raise a non-critical alert. Good example of that is if we see snapshot usage changing. There's an alert in here for rapid snapshot growth. So if we see a snapshot that's been ticking along that suddenly gets much, much bigger, it'll ping you a quick email, it'll flag it as an alert just to raise your awareness of that.
That could be a sign of something untoward, like an encryption virus or something, if the amount of snapshot increases rapidly.
Yeah. If you suddenly see an awful lot of them, absolutely, it'd be early warning of that. Day to day, it tends to be a sign that someone's taken a snapshot and done some changes and forgotten. We had a great example a couple of years ago from a customer. They had a SQL database, which was the kind of the core of the business, about 8 terabytes in size. They'd taken a snapshot on that before the DBA team did some work one weekend. And it had all gone through absolutely fine, all the updates, all the patching, no problem at all. And they just carried on as normal. About 3 months later, they had another set of works on the database, but this was going to be touching nearly every single record. So it was a big kind of update on the back end. And the IT team came in the morning, on Monday morning, to an email sat in the inbox saying, yeah, we're seeing unexpected growth on this the snapshot for this database. That manual snapshot that taken 3 months earlier, overnight had gone from 300 meg in size to about 10 terabytes. Massive change.
That's a big jump.
Yeah, and it's the kind of thing that could easily just sit there and soak up space on your storage. Oh, we actually had a call from the user just before a conference, and he said, look, I'd come in the morning, I'd put my coffee on, sat down, seen that message. I could see which virtual machine it was related to. I could see it was a manual snapshot. I could see when we'd taken it. Instantly knew what it was, picked up the phone and spoke to the database team and just said, yeah, that snapshot we took 3 months ago, do you still need it? And they said, oh, no, we'd completely forgotten that was there. He said it was found, resolved, and cleared before I'd even finished my first cup of coffee in the morning. He said the business didn't even know it happened. And that's the kind of scenario that these non-critical alerts are there for. It's giving you that heads up so that you can nip things in the bud. You can spot things that have changed and react to them before the business even notices.
I would assume that these critical and non-critical alerts can be sent by email as well. You don't have to log into the interface to see them.
Yeah. You've got all the normal alerting. A lot of them will raise support tickets with us as well. So we've got some accounts where the first time they've heard of this is they get a phone call from support, just letting them know that an alert's been flagged somewhere in their estate. But yeah, lots of places where we'll notify you of this. Just moving on through the interface, I'm just conscious of time. Call home on the top right. That's actually a separate type of alerting using SMTP. So you've got IntelliCare for your monitoring, you've got monitoring within the array itself, and we've also got Call Home, which is also sending alerts into us. So multiple means of monitoring the health and just making sure everything in the estate it's ticking along nicely. And we'll flag here if you've got any systems where call home has been disabled, because that we do recommend that's enabled for everything. Capacity usage and space savings. If you've got a modern array like this, which is thin provisioned, it's got dedupe, it's got compression, everything's in line, the amount of space you're provisioning to virtual machines doesn't directly relate to the capacity of the array. So we always show this is the true usable capacity of your array. This is how much free space you've got. And this is how much is actually being used. Because you can't see this from vSphere, you need to monitor space usage from the arrays. And we make sure it's crystal clear how much data you've got, how much space is being used for snapshots and change tracking, how much space is reserved. And the combination of being able to see that really quickly and also seeing your current data reduction rate means you can estimate how much extra space you've got very easily. Here, 140 terabytes of free space, 2.7 to 1. We'll get about half a petabyte on this lab before it fills up.
And that's across all those 12 systems, I'm assuming.
That's across all 12, yes. That's globally across the whole estate. You'll see in a second we can drill down to the individual arrays. And of course, we can see where they are, and we can see the health check. So we've got a few systems. This is a lab, so the lab gets mistreated on a daily basis. So most of our customers are going to have everything healthy and no critical or warning. Lab, it kind of tends to be the other way around because we deliberately want to kill things and make sure they still tick along. On your point, Lee, about looking at the individual arrays, if we click on arrays, and if I come down here, the one I know has got some workload, now we're looking at the same set of data for an individual array. So we can see the capacity usage at the top. We can see the dedupe rates, getting about 4 to 1 on this one. But now we can also see the information about the individual array. So we can see the model number. We can check that it's active. So here, active, active, both controllers are running data. We've got a link to the management of the array itself. So from IntelliCare, I'm not logged in the VPN, so I can't get onto this at the moment. But from IntelliCare, if you're logged into your internal network, single click and you can connect to the management interface of an array if you need to make changes.
Nice and quickly.
You authenticate again for security because you're now authenticating using a different set of credentials to log into the array itself. And best practice is you'll have different credentials for every array. So again, it's all about keeping those layers of security in there, multiple layers, so that you're not vulnerable to attacks. And the great thing about this is because you're not logging in very often, and because it's minimum credentials when you do, and you can set very granular controls on the accounts as well, it does help against things like a spear phishing attack. If you get an attack that's actually targeting the IT team, well, 9 times out of 10, they're not going to have logged into IntelliCare or IntelliFlash on a regular basis. You're not going to get credentials for the array. And that means that things like snapshots are really secure as an additional level of backup and protection for the data for the business.
Sounds good.
So we can see the controllers, we can see the uptime, we can see the firmware numbers, all the stuff you'd expect to see. If we look at the health check, we can see the health status for this individual array. We can go onto the system information and we can see the specs and the details. We can check that it's been uploading its logs, and we go through these automatically. We've got a big database where we're actually checking for patterns, checking for faults, checking for trends within the customer base. So that's where some of the predictive analytics comes from. It's from having that kind of cloud intelligence and analytics, monitoring the logs and going through logs for basically a global install base, rather than relying on just the alerting within a single array. Version history, we can see when they've been updated. We can see which IO cards are fitted, and we can check the link status. So here, we've got some 10 gig ports, which are running nicely. We've also got some fiber channel in this array. We can have up to 12 ports, 12 data ports per controller on top of the kind of management ports and also the interlink. So lots of options there, and you can get a decent idea of the status from here. One of the nice things on the capacity side, and this is always interesting to do live because what I see here changes every single time because it's based on real data. If I go onto the space trend analysis, this is going to actually look at the estate and actually look at how capacity is changing over time. And as look what have it, we've got a decent example. So this is based on the real current growth rates of the array. So whatever the current growth rate is, we can see the current date in the middle. We can see historically how the capacity on the array has changed over time. And we can see the projection as to what the capacity is projected to be in the future. And if we actually select an array, here we've got an alert at 70% full. We go to critical at 80%. We would actually show you at the point at which you would hit 100% full as well, at which point everything stops working. As with any storage array, if it's 100% full, you can't write any more data. But you actually get the dates and the times. So you'll see down here the exact point at which you're going to hit the warning levels, the critical levels full. And we've got customers that they will literally take a screenshot of this page and use that in their report up to finance or up into the kind of the IT director. They say, look, roughly 12 months time, this date, we're going to be running very, very critical on storage. We need to make sure we've got space in the budget and we've planned for that ahead of time.
That's always been a challenge, hasn't it? Capacity management and prediction for the future.
Yeah, and it's quite good. It's got to be fair. Our VM Store product, the sister product to this, takes it a step further. VM Store is really, really good at this. But IntelliFlash is pretty good. And we've also got the advisor report, which also acts to give you the same information. So the advisor report, again, because we don't expect people to be logging into this, it's nice to get in your inbox every week, every month, however often you want, to any number of people. A simple report that's going to give you a heads up on the health of your estate. This is going to say, look, how many arrays you've got, how many are being monitored, whether any have dropped off monitoring at the moment, how much capacity you're using across the whole global estate, and where the bulk of the capacity is sitting. Same for metadata. So we keep track of how much metadata we're using. If you're running deduplication compression on a big data set, that'll start to use metadata. But generally speaking, these days, we've got a lot of headroom in the metadata on the hardware. And you get this space usage projection. So same kind of analysis, but this is now saying across an entire global estate, have you got any pools that are going to be getting to the 70% full within the next 6 months? Within the next 12 months, what's that going to be looking like? So you can see 12 months ahead, which pools are getting full, and you can also see if that is a trend. So I can see here quite clearly that we've got a few that are full now, and actually they're going to be getting pretty critical within the next 12 months. I know in 12 to 18 months, we're going to need more capacity on at least 3 of the pools within this estate, or we're going to need to move some of that capacity around to these pools that are below 50%. So it just gives you a heads up in your inbox to let you know that, look, you're running a bit tight in some locations, and you can then just go to the user interface and take a look at where the space is and decide whether it's appropriate to move things around or actually whether you've just got a location that's going to need a little bit more investment. You can see your overall data reduction rates. So we can see here we've got some pools really, really good. Workloads like VDI or software development can get absolutely incredible data reduction rates. Global average is honestly around 2-3 to 1. That's what most virtualized estates will see. And then you can see how many alerts you've had since the last report came in. So how many alerts? Have you got any systems where support is starting to expire? Have you got any old systems where support has expired? And that's it. Very simple report, but just a good little heads up on kind of your capacity and health status for your estate that can just pop into your inbox whenever you need it and let you know kind of what's going on.
That's quite powerful though, isn't it, having that information sent to you on a regular basis?
Yeah, it means all of this is designed just to make life easy. So you don't need to be logging in and remembering to log in to check. You've got with IntelliCare that peace of mind that we're monitoring these anyway. We're monitoring literally thousands of arrays all across the globe 24/7. So you've got that peace of mind that monitoring is happening. You've got that report that can come to your inbox so you can keep an eye on it yourself. If you ever do need to open a support ticket or contact us, if you click on the support tab, you'll actually see your account team. You'll see all of your estates. You'll see all your arrays, when they're in support until. We just try and make it as easy as possible to keep an eye on things. One of the most powerful areas, though, day to day, I've not come on to yet. So if I go on to one of the demo systems and go on to the performance tab, with IntelliCare, you get 3 years worth of performance history for every single array on your estate. So you've always got a baseline of how things have been performing. You can see how the business has grown. You can see how things have changed. We can see the CPU load. Most customers are running these arrays at 20-30% CPU. There's a lot of headroom because they're designed to take 6 expansion shelves and to run inline deduplication compression even after they're expanded. There's a lot of headroom. There's a lot of performance headroom in the controllers, and most customers are nowhere near the limit of what these controllers can do. Network usage in IntelliCare is very high level. This is very much just about making sure you're actually load balancing across the ports effectively. You've not got a port that's idle, that's got no traffic. You're actually making use of the bandwidth and you're spreading the workload around. We've got cache hit ratios. For hybrid systems, it's one of the most important metrics to keep an eye on. If we always aim for 95% plus cache hit ratio on a hybrid system. That's where you get near flash performance. You get very good latency. Almost everything's coming from the SSDs, and it's very rare that it's having to drop down to the disks to pull data from there. You do find with hybrid, with any hybrid storage array, once your cache hit ratio drops and you start putting a lot of data to the disks, that is when the users start to notice to slow down, because it's a big difference between flash performance and a spinning disk array.
I think we calculated once like something to give people an idea of the difference between a spinning disk and solid state disk. Its difference between supersonic speed and walking pace is a rough example of the difference in time.
Yeah, in terms of latency, it's there's a reason that pretty much everything we do today is based on flash. I mean, you look at your smartphone, that's flash. You look at laptops and desktops for almost every estate, that's flash. People's home computers. It's a night and day difference in performance, and the vast majority of enterprise estates today are flash.
But there's two metrics really that matter, isn't it? One is the latency. So with a spinning disk, it's the time it can get on cylinder to start reading the data. But then secondly, the amount of data it can read and send across the network, which is the actual throughput. And the difference is really large, isn't it, between SSD and normal spinning disk?
Yeah, massively. The thing that people always notice though is latency. When you've got a system that's live, when you're deploying a new storage array, obviously we're going to be looking at IOPS and throughput, and we're going to check the spec and make sure that we're recommending something that's appropriate, that's a good fit for the business. But actually, once you're live, once you're running, latency is what you care about. The end users, the users of the estate, the department heads, the software, the databases, they don't care about IOPS and throughput. When they slow down is when there's latency. If there's a delay reading something from the storage, that's what you see. And that's why latency is top. Latency is top of the graph, because latency is the thing that business cares about. Latency is where you see a performance change. But then you can see, as I'm mousing over any point in time, we're also showing you what the IOPS and throughput are, because if you get a spike in latency, it's normally accompanied with a change in behavior. If I just zoom out to a year, we'll see how performance has changed over time. And you can see there's a point in time here where performance dropped off the cliff. And this is almost certainly going to be a period where we were moving the lab or we took a system offline. But you can see very, very quickly exactly when that happened. You can zoom in no time at all and say, okay, yeah, it was 7 o'clock, November last year, that's when it went offline. And I know for a fact that's when we actually did a data center move. So a lot of the arrays went offline for an extended period and were physically moved to their new location.
And I think sometimes it's useful to be able to go back in time, because a lot of users don't report an issue until later on. It might be a week or 2 weeks later that they report some issues. And then if you don't have the information for that point in time, it's a challenge, isn't it?
Yeah. And that absolutely, that's where the history is so useful, because you'll get a user coming in saying, look, this application's gone slow, or you'll get a report coming in or a ticket coming in. And if you look at the data and you can say, well, actually, yeah, it is running slow at the minute. But for the last 2 weeks, it's been running 3-4 times the amount of IOPS that it had done previously. If you can see the point in time where that change happened, you can now go back and have a very different conversation, because you can go and ask and say, did anything change on this date? Have we started using any more features? Has someone run a script and forgotten to turn it off? Are the developers running some testing? Finding the date at which something happened, you can much more quickly get to the root cause, because you can find, okay, what did change on that date? If you're doing change control, you can look at the tickets, see what changes were made on that day.
Yeah, it could be a patch update or something else that could have affected a particular virtual machine or set of machines.
Exactly. So seeing the change in behavior. If you've got a physical problem on the storage, again, it's the smoking gun. If someone says there's a performance problem, and you can come in here and we can filter down and we can say, like, actually, it's just one pool because it's a particular project, and it's actually a particular LUN. And you can say, like, let's look at the data. I'll probably pick one with no data. Yeah. Challenges of a lab system. And you can say, look, let's have a look at the data for that particular LUN, that particular system. Really useful to see the history. And if you see high latency on the storage, you know it's a storage problem. Give us a call, open a ticket, we'll look at it straight away. More often than not, though, you'll see actually the storage is healthy, or the storage is just doing everything it can, but there's been a change in behavior. And if you're using one of the VMware protocols, this gets even more powerful. So on VMware, we've got VMware NFS. For Hyper-V, we've got VMware SMB. And with that, you get the same metrics. It looks very similar. But if I go to the data sources, I can now drill in, pick a particular ESX host. I can pick a particular virtual machine. And now I'm looking at up to 3 years worth of performance history on the storage array for an individual virtual machine. So this is not pulling data from vSphere. This is not just the top end of the performance. This is what's happening on the disks for an individual virtual machine. And now we can see very, very clearly when there's any behaviors in a particular application. And again, we can click and drag and zoom in. And we can see here there's a period for a few days in April where that went offline. But we can see that in the main, actually, let's look at the last month. We can see at the moment, latency is really consistent. So we're running here. This VM's running 18, 20,000 IOPS. It's consistently seeing under a millisecond of latency. If someone was calling me with a concern about this virtual machine, I can look at this and go, right, well, it's not storage hardware. The hardware is absolutely fine. We've got no concerns there. We can start to look at the software layer. We can start to look at the virtual machine. We can move up the stack.
I think that's sometimes really powerful when you can actually work out where the issue is, because sometimes it's so difficult, it could be anywhere.
Yeah, well, this is the challenge. There's a lot of storage arrays out there that have, these days, very good monitoring. I'm not aware of anybody other than Tintri that have storage arrays that are natively aware of virtual machines to give you both ends of the picture. Most of the monitoring that happens at the virtual machine level, what's happening is the management software for the storage array is polling vSphere, and it's linking virtual machines to LUNs. And the challenge is all of the VM-centric data is coming from the hypervisor. Well, you've got quite a long stack of hardware between that and the storage. You've got well, let's start with the virtual machine. You've got the virtual machine, because a problem with the software there can cause latency. You've got the hypervisor, you've got the HBA or the network card on the storage ports, you've got all the storage cables, you've got the switches, you've got the cabling to the storage array, the controllers in the storage array, the disks themselves, the LUNs, any quality of service settings, contention. There's literally a dozen things between the virtual machine and the disk. And a problem with any one of those, and that can be as simple as just being overloaded, contention, lots of virtual machines sharing the same resource. It could be contention on a network port. It could be you're just running too much throughput. If all you can see is the VM side of things, and on the storage array, all you can see is a LUN, which is containing another 20 or 30 VMs, really hard to see where that problem is. Really, really time consuming. And I talk to teams all the time who tell me that when they get that kind of issue, it's taking hours or days of going through the logs of the host to try and see where the problem was or where it started from, which host was first. Because the reality is, if you get a bottleneck like that, it's going to slow down a lot of different virtual machines. Everything that's saved on that same LUN or that same piece of storage is going to be affected in the same way.
I think the other thing is a lot of people are running their vCenter as a virtual machine on the same infrastructure in some cases. So again, anything that's affecting the hardware and network is going to affect vCenter as well. So that data can be, compromised.
Yeah, it's true. In that case, you'd struggle to get the logs. Whereas here, you've got logging happening in real time on the array. And in IntelliCare, we are looking at slightly historical data because this is really designed to be a long-term planner. So here, we're actually updating this once a day with the latest data and giving you 3 years of history. If you need to troubleshoot live for a problem right now, if we look at IntelliFlash on the array itself, you've then got real-time monitoring that still understands virtual machines and can still go to that VM level. And to the best of my knowledge, for actual classic storage arrays, I don't believe anything other than Tintri IntelliFlash and Tintri VM Store have that ability to do real-time monitoring at the VM level over the classic kind of storage protocols. If you're using iSCSI, using NFS, using SMB3, it's really, really powerful. And for the general features, there's a lot more in here. But as a quick tour, that's how we tend to introduce IntelliCare to new users, to people that are new to the system. That honestly is the primary interface day to day. It covers checking the health of your estate. It covers making sure you've got enough capacity and you can plan it for the future. It covers making sure that you've got the hardware's healthy, you can contact support, you can see all the support details, you can troubleshoot performance and look into performance issues. pretty much everything you'd need to do on a storage array day to day to make sure your estate's healthy, you can cover from this one console.
Can you give us an example of a critical alert then? Can we drill into that and see one? What information is provided?
Let's see how the lab's been dying. Here we go. So we've got fan failures. So typically physical hardware faults. Something physically has happened. So here we've got fan failures. It could be a disk failure. It could be someone put out a power supply. We've got spare disk unavailable. So we've had a disk failure. The spare's kicked in. It's rebuilt. But now that array's warning that we don't have any spares. It needs that spare disk replacing so it can use a spare. Like I said, this is a lab. We deliberately mistreat some of the systems in the lab. They're not healthy boxes.
Yeah, but it's quite detailed, isn't it? That the information you're getting, so it's really useful.
Yeah, it's going to tell you which system. It's going to tell you where. It's going to show you the trending, so you can see kind of. We had a lot of alerts in September on the 20th. So it's interesting if you see a spike like that to go and, if you're managing an estate, to go and have a look and say, what happened on that day? Did we have some engineers in? Was there some work being done? What's actually happened to trigger the alerts on that day?
Well, that's been really useful. Thanks ever so much for that. And I'm sure there's more depth we're going to cover at a later stage. Also, we are working on getting some of the SQL capabilities for the VM store ready to go as well at the moment between us. So that'll be something we could show maybe in a week or two's time once we've got everything set up. So I'm looking forward to doing that. But other than that, thanks ever so much for your help today, and I think that's going to be really useful for any of our viewers as well.
Lovely. More than welcome, Lee. Anything.
Thanks ever so much.